Bismillahirrahmanirrahim. Hello everyone. Welcome back to the PL-300 exam preparation series where we are looking at the second learning path, model the data. In this video, we are going to discuss the topic improve performance by identifying and removing unnecessary rows and columns, which is part of the section optimize model performance. So we continue our discussion on improving the Power BI data model performance, and one of the very important aspects that we discussed in the previous video was related to the size of the data model. So we are always trying to reduce the size of the data model. So that is the prime effort that we are doing. So this is again a topic which is related to the reduction in the model size, and we can do this by first identifying and removing the unnecessary rows and columns. So let's first talk about the columns that we have in a data model. So our data model can have multiple tables. There could be multiple dimensions and multiple fact tables, and then within each table there are multiple columns. So any column inside the data model table serves two main purposes. The first and the foremost purpose is the reporting. So a column is included to achieve the report designs that appropriate, filter, group, and summarize the model data. So once we have a column inside either a fact table or a dimension table, then the purpose of that column is to enable the report design and analysis. And this is done by either using that column for filtering, by grouping, or by summarizing the model data. Next, there are columns which have nothing to do with the reporting itself. So they provide no information related to any of the things we are looking in terms of the report objectives or report goals or even the report KPIs, but these columns are necessary for model structure or for providing supporting functions in the model. So one of the category of those columns are the ID columns, or which we call as the columns on which the model relationships are built. So these columns are providing no information related to reporting, but these are part of the model structures. Then there are certain columns that are required for building model calculations. We are going to look at this once we are exploring the DAX. Then there are certain columns which are required for the security roles. This is a topic that we are going to explore in detail once we are talking about the row level security. And then certain columns are required even for the color formatting inside the conditional formatting options available through DAX. So just remember that there are two broad categories of columns, one which are directly related to the reporting and the others which are just related to the model structure and are there in a supporting role. So if your data model has columns which do not serve any of the purposes that we've just discussed, then it is important that you can remove those columns. You can probably remove those columns because they are just sitting there and occupying space inside the data model and offering nothing. So if you are removing columns, then this is also referred to as the vertical filtering. So if you are removing unnecessary columns in your data model from any of the tables, then this is also referred to as the vertical filtering process. Why it is called vertical filtering? Because the columns are the vertical entities in the data model. So that is why it is called as vertical filtering. It is recommended that models are designed with exactly the right number of columns based on the known reporting requirements. It is again emphasizing on the same thing that you should always keep the right number of columns, only the columns which you feel are important from a reporting perspective. Similar to the columns, rows also play a very similar role. So the tables inside your data model should be loaded with as few rows as possible. So make sure that you do not have redundant records, the records which are never required in any of the reporting requirements that we have just seen. So in order to load as few rows as possible, this can be achieved by loading filtered rows into the model tables for two different reasons: to filter by the entity or to filter by time. And this process of removing rows is also referred to as the horizontal filtering. So horizontal filtering is that we know that the records are the horizontal entities in the tables. So if we are removing the rows from the data model or from any of the table, then this is called as the horizontal filtering process. So let's first look at what is meant by filtering by entity. So filtering by entity involves loading a subset of source data into the model and then use parameters to reduce the size of the data model. For example, instead of loading sales facts for all sales region, only load facts for a single region. This design approach will result in many smaller models, and it can also eliminate the need to define row level security. So we can do the horizontal filtering by entity. So let's say you have hundreds of sales regions in your data, and you know that the analysis that you are going to perform only requires very few sales regions. Then there is no point of loading extra sales region. Or if you feel that there are sales regions which have to be loaded on runtime, then you can use the query parameters. So we have had a look at query parameters. Query parameters we have already explored in one of the previous videos, so you can go and watch that video again, and where we looked at how these parameters can be linked to the data source. But for the sake of this video, just remember that the query parameters can be used to reduce the size of the data model. And another thing that we are going to explore in a lot of detail during one of the videos in the fourth learning path is going to be the row level security. So the row level security also is one kind of a filtering, but that filtering is not related to actually the data being filtered. It is just the data is being filtered at a view level. So it has nothing to do with the data model size. So just the summary of this point is that you can reduce the data model size by doing the filtering based on the particular entity that is in question. A more realistic and more followed approach of reducing the data model size is by using the filtering by time feature. So what is filtering by time? So filtering by time involves limiting the amount of data history loaded into fact type tables and limiting data rows loaded into the model date tables. It is suggested to only load data which is required for reporting. It is helpful to understand that time-based Power Query filters can be parameterized and even set to use relative time periods relative to refresh date, for example, the past 5 years. So again, this is a very important thing that you need to understand, that one of the most common ways of reducing the size of the data model is to apply filtering by time. Let's say you are required to analyze data for the past 5 years, but you have the data available for the last 15 years in your data repository, in your data source. And instead of loading the entire 15 years data, just load the data for the last 5 years. So although the data is available, but you just load the data which is required for the reporting. And this can also be parameterized through Power Query filters. So once we are going to look at the filters in the report view, and also we have also seen the parameterization in terms of the Power Query parameters, these can be combined to effectively improve the performance and improve the size of the data model. So this is how the horizontal filtering is done inside of Power BI, and this is very important in terms of the reduction in the model size. So just to conclude this video, just recap some of the data reduction techniques. So we have seen that removing unnecessary columns, unnecessary rows are very important. Then group by and summarize, we are going to explore this in the next video, that how we can use group by and summarize to raise the grain of the fact tables, or in other words, we can reduce the level of detail. Then data column types are also, which are is also that we have explored in the previous video. Similarly, one important thing is that once we talk about DAX, then we have the capability to add columns and create new columns in DAX. But the preferred approach is that if you have to create new columns in the data, whether it is to be done in the fact table or in the dimension table, then instead of doing it inside of DAX by using calculated columns, use the Power Query editor to create custom columns. So this is something that is very, very important, that if you have to create new columns, then do it in the Power Query. In fact, there is a very famous saying from one of the Power BI experts, and it is referred to as the Roche's maxim, that if you have to do any transformation, or if you have to create especially new columns, then do it in the source. If you cannot do it in the source, then do it in Power Query, and then only do that in DAX if there is no other way of doing it in either Power Query or in the source. So just keep this this particular maxim in mind, that this is the best way of improving the performance once we are working in Power BI. And another thing which we have already talked about in one of the previous videos is that you need to disable the auto date time setting. So we had a look at this once we were talking about the load settings. So if you disable the auto date time setting, then this also disables the process of creation of auto date time table. So for every date column or date time column, and a table, a hidden table is created in the backend by Power BI, and this is just a redundant thing. So if you have the auto date time functionality enabled, just make sure that you go and disable this functionality. So these are some of the points that some of the points have already been discussed in previous videos, and this video we specifically talked about columns and rows and how you can remove the columns and rows. So that's all for this topic, and I will see you in the next video.